I lost to the worst player of all time. I just lost to the worst player of all time. Bro, I'm so bad at this game. Ugh.
Yes, sir, boo boo.
It's not on in Pekka's spot. I mean, Megan's spot.
Alright, let's begin this past paper. Further Mechanics 2020. Let's go. Let's just do it, lads. 3, 2, 1. Okay, so. Okay. Okay, this is pretty easy. We just use the equation. Okay. And we just sub it into this formula right here. I'll just leave it as a fraction in it, lad. Yeah, my. Okay. I want the magnitude of it, so I'm just gonna. What good is it? Calculated, isn't it? Nice and easy. First questions are nice.
Well, the first questions are always nice.
Yes, sir. Okay. Angle between the direction of the impulse and the direction of motion of P. Immediately let's see the impulse. Okay, then we're just finding dot product. The impulse is like this. It's the angle between them.
I doubled down and it works.
Okay, so we have the vector 4, 3 and the vector. The angle between these two vectors. Okay, let's just sketch them out. I'm just going to do the dot product now. I think that's what it is. And we obviously have the magnitude already. Calculated from the question above. And then we have root 4 4 squared, add 3 squared, and we'll cos minus these suckers. And we should get our answer right. That would be 4 multiplied by multiplied over 2. 1, 3, over 3. Okay, 112 degrees. Next. These questions are always nice because it's just a straight line. Truck with mass 1,200 kilograms. Here the instance is V. The resistance to motion of the truck. Okay. The driving force given by P equals FV. Okay, it's talking about a deceleration of the truck for the instance when V is equal to 25. So you can find the driving force. Pretty simple. It's just 1,000 newtons. And then we know we can use F equals ma. And the resultant force, which would be 900, would actually be, because it's a deceleration, we can do that. 900 plus 9, it's going to be negative, right? 25 equals the mass multiplied by deceleration. So we just get we're just going to get negative 0.1 and I'll give it to, I think that's correct. Okay. Because they already mentioned deceleration, I don't know if I should mention that it's negative. Because I don't know, should I? This is the acceleration. Acceleration is negative because it's decelerating, but it's asking for the deceleration. So should I keep it as positive or negative? Okay, I'll just, therefore deceleration is equal to this. No. B. Dang, boo. There's no one watch.
Hold on. Anybody want to watch you revise, buddy?
Okay, next sine theta equals 1/20. What exam do I have next? A-level fluid mechanics.
B.Z.I do it.
Okay. Next, we can drop it over theta, sine theta equals 1/20. Okay, so we have to 1/20, so we can model this truck like this. Okay, at the instance where it's moving at V, the resistance of motion to non-gravitational forces is still the same. So it's always the same questions. 909 V. Quantum rate. Okay, as obviously force, the driving force. And we can then just put our gravitational forces of resistance. And then we'll get, this is obviously 1200 G. One here. So therefore this one is just 1200 G sine theta. And then we can have, F equals ma again. Hold up. We'll do. Let me read the whole question because I didn't read the whole question. The engine of the truck is working at a constant rate of 25 kilowatts. The truck is moving up at a constant speed of v meters per second. Okay, it's a constant speed, therefore acceleration is 0. You just have to see that. Therefore, when you do F equals ma, F is equal to 0. Therefore, we can do.
I'm gonna fart again. 3, 2.
Buddy, come on.
No one was silent.
Come on. Okay, then we do F equals ma, F is 0. And then we just have our values. That's the driving frequency, and so equal to 0, sine theta equal to sub. So we'll get nice values. And 60 G. Okay. Okay, I just want to move everything to the other side because it's kind of annoying. Okay, and then we have our nice values that we can just pop the calculator and see what happens. So 969.81 plus 900, and that's just nice values. Let's see what we get. Okay, we get 2 values. Let's make sure everything's correct. Okay. Seems correct. Okay, V is then equal to 15.37 because V has to be greater than 0 because V is a speed. Correct. Should be enough. Let's make that 0.8 to 3 significant figures. Okay, question 3. Particles A and B have masses 3m. Get the time on it. Te pana, odio, que ta tipo te pise pana, topito pito, patopito, popita, patopi. Okay, the particles are moving in the same direction, same movement. In a smooth horizontal surface, they collide directly immediately before the collision. The speed of A is 2u. Okay, the speed of B is u. Drawing a diagram in these type of questions is a must, I'll be honest. And the coefficient of restitution is just e, so e equals e. And now we can show the direction of each article unchanged. So I'm just going to make both of them go to the right. I always like doing that. You can do it however you want, but I like doing this. And we have to go ahead and conserve the momentum. That's what we have to do. We conserve the momentum. So we have 3m, 2u, negative u because it's going in the opposite direction. and you'll get 3n VA at 4n VB. I do kind of want to put the chat on just because it's kind of interesting. Nosito baby say pana, pana, oh baby pana. Decotito baby say pana, to you. Decotito baby say pana, to you. Ofitato peso, pato budo. Decotito baby say pana, pana, pana. Krish is in the stream. Let's think so. Hey. No, wait. Okay. Now let's conserve the momentum. Okay. Let's cancel the M's, of course. Okay. And then we have 3VA at 4VB. And we'll get 3VA at 4VB. And now let's go the Newton laws of restitution, of course. Separation over approach. So always, this is the part where most people get stuck, because they always put the U at the top instead of the bottom. So I was going to go ahead and put the U at the bottom, just easy. And then you have VB minus VU, VB minus VA, because VB must be greater than VA, because or else they'll topple over each other, which you can't do, of course. So VB minus VA. Okay, what's the question actually want? Show the direction of motion of each pole is unchanged. Well, if we prove that both of them are positive, we're proving that none of them change direction, because we set that to be positive. So we have 3E plus VA is VB, sub 1 into 2, sub 2 into 1, okay. Alright, let's put them all to one side, all the U's on one side. Ooh, pretty sure they're both negative, as we can see here. So we get VA equals here, and since E is in between 1 and 0, I actually don't know if it's positive or negative. I mean, could be positive, unless they have some conditions on E that they haven't told me about. Let's carry on that. So We have e's in between 1 and 0. Let's have the clock up. So we have 1 hour 10 minutes left. Okay. Okay, let's just sub VA into 2. Because I want to see if we can try and get okay, you get 9/7 UE. Ooh. The direction of motion of each of the particles is unchanged by the collision. Okay, this has to be positive. Okay. Okay. VB must be greater than 0. Because E is greater than 0. Fine. Therefore, did I do something wrong? I mean. Yeah, it must be wrong because I get a positive value. That means it's changed. That is changed. Okay. Buddy. What has happened? Am I using laws of restitution incorrectly? No. I don't see it. I don't see what I did wrong. I mean, did I sub it in incorrectly? Oh my. No, it's fine. It's fine. Oh, okay, I'm just gonna circle it, come back to 8 marks still. Pain, that's pain. After the collision with A, particle B collides directly with a third particle C, mass 2. Gives that rest. Wow. Okay. The thing is, I need to know what VB is. I need to know what V and V is. I don't think my values are correct. It doesn't make sense. So I'm going to go back to the question later. Okay. 4A. Okay. Well, what we can do in this equation here, this question here, we can do the U dot W is equal to V dot W. We are given the mass though, so I feel like we should find the impulse. Yeah. Oh, should we though? I feel like that should be in part B. I feel like we're able to just do it. I don't know. Are we the? No. So I'm gonna go ahead and find the impulse. Okay. Which will just be 0.5 minus the final and the initial, and then we have this right here, negative 3, 2. Okay, that's a good direction here. Hence, the wall is 2, 3 as required. I don't know if that's legal. Can I do that? Maybe, maybe not. But we'll go ahead. Go ahead, bruh. Okay. Next we can do this equation right here. So we're gonna do negative EU dot I is V dot I. Do we know the impulse is negative 3, 2, and we know V, and we know the impulse. Wow, this is just super easy for us. To get all the method marks though, it's better if we do it like this first, and then show that we've, whatever, times by the magnitude of the impulse. Just so that we have this here. Now we go ahead and the final velocity is 1,6 calmest. One before 7,2 calmest, and we have the coefficient of restitution is the unknown. So we're going to go ahead and find these values right here. So we have negative 3 plus 12, 9. We have negative e multiplied by negative 21 plus 4, and we just simplify this all out, get some nice values. We'll get 17 e is equal to 9, e equals 9 over 17. Wow, so lovely, wow. Okay, that's our value of the coefficient of restitution. That was a pretty easy question. And now we're on question 5 here. We have 5, 1 hour left. Okay, so smooth uniform sphere P has mass 0.3 kilograms. Another small uniform sphere Q with same radius as P has mass 0.2 kilograms. The spheres, okay, spheres are moving along a horizontal surface. Wait, before I read all this, I always like to see this here. So the lines of centers are parallel to the I direction. So I like to just draw my diagram like this before I do anything else. So, beautiful. Okay, 0.2 P, call that Q, and this is 0.3 kilograms and 0.2 kilograms, and we have the directions of the P. So P, I like to do it to the center, like so. That's just 4, 2, and we have the velocity of Q being negative 3, 1. Textbook question. And next, okay, the kinetic energy of Q immediately after the collision is half. Ooh, is half the kinetic energy of Q before the collision. Okay, that's already making me think consider that a bit later on, but let's just see what, with the information we're given here, let's see what we can infer from all this. So, we can go ahead and make this a bit more nice. We can make our diagram a bit nicer here. So, the usual diagrams that we do for these, and we're just gonna have it nicely. It's just good. It's good. So I like to have them like this. The bison method. I call this the bison method. This is the goat. VP, VQ. Let's make them both on this direction right over there. Now we just do the normal stuff where we do the conservation of linear momentum. We find the Newton laws of restitution. Okay. And velocity of P immediately after the collision. Well, okay. P immediately after collision, so we're just gonna get two equations. We're going to, but we're not given covariant residue between them, so I'll just see what we have. Okay, I'll just see what we're working with. So good. Do I want to keep it like this? No. Just no. I just don't. Can I make it more pretty? Yes. If I multiply by 10 on both sides, you can just make it look much nicer. So that's our conservation of linear momentum. To find the velocity afterwards, we're going to consider vertical components and horizontal components. Come on. Think, monkey, think. Do you do this? Boy, oh boy. Okay. By considering the component this is not a nice question. This should be pretty easy, but I'm just struggling for no reason. Just because we're not given the coefficient of restitution, I'm going blank. And a question like this, what? This is absurd. This is a crazy question. It's pretty easy, but I just don't know. I just can't see it right now. I'm not seeing it. It's a really easy question. I have a further mechanics exam tomorrow. Yeah, long day for me. Okay. Clearly, we can't do this question without considering this statement right here, that the kinetic energy of Q immediately after the collision is half the kinetic energy of Q immediately before the collision. So I'm going to go ahead and consider the kinetic energy of Q. Good. So we know before we're gonna have half. What is it? What's the mass of Q? 0.2. Half okay, the speed before is root 3 squared, add 1 squared, and then all that squared, which will just give us a nice value of 10. So that's 2, 10, 2, 2, half of 2 is 1. So the kinetic 8. Yep, and just 1 joule. Hence, the kinetic energy after is going to be 0.5 joules. Yes? It must be. So, we have half, we have the mass, and we have the components of velocity. And we know that the velocity, the component of velocity that is perpendicular to the lines of centers are unchanged. So, only the x component changes. So we have kinetic energy of Q. 1 stays the same. So the okay. The 1 stays the same, so we can do this. And the component that is perpendicular to the line of center, which we named VQ, is not unchanged. So we're given some nice values here. So 2 times 0. 0.1 1 plus VQ squared. Okay, and that's equal to 0.5. 0.5 divided by 0.1 get 5. 5 equals 1 add VQ squared. 4 equals VQ squared. Oh, beautiful. It works out beautifully. We just get 2 meters per second here. That's lovely. That's absolutely lovely. We just get 2 meters per second. And that's obviously positive because it's a speed. We don't have to do the plus minus. Okay, next we're gonna that's part A. AI. AI. Now let's consider the second part of this, where the velocity of Q immediately after the collision wait, what? Bro. Okay, I just found VQ, which is not actually answering the question. Okay, now they have this in a weird setting, because how are you meant to do that? How are you meant to do part I without doing part I? So we know VQ is 2 meters per second. Okay, fine. Second part is easy. Okay. 2-1. Just 2-1. Well, were you on a 2-1 in uni? You're on the first. Good man. Okay. Bro. No. Come on. What's happening with me? Why am I this bad? Okay. 2-1. That is the velocity of V afterwards. and then sub VQ equals 2 into 1, so we have 6 equals 3 VP. But how would they possibly do this without finding? That's what I don't get. How do they possibly get it? Okay, that's just easy here. Well, here are the two speeds on velocities because they're vectors. Next, they want the coefficient of restitution between P and Q. Well, we just use the equation for the coefficient of restitution, where it's separation over approach, as we did in the previous questions. So we're just gonna go ahead, bruh. We're gonna have 7 at the bottom, and we're gonna have VQ minus VP at the top. So I'm just gonna go ahead. 70 minus VQ VP. Okay, we know VQ and VP. They're just gonna sub them in. VP is 2 over 3. VQ is 2. And then just go ahead, bruh. Four over 21. That's oddly similar to the previous questions. But let's go to part B. The size of the angle through which the direction of motion is deflected by the collision. Well, we just have to find the dot product, the angle of deflection, the motion of P. So we know the final velocity of P, we know the initial velocity of P. So we can just find the cross or dot product of them. So let's just dot them together. So 4, 2. I'll just do it straight away. And the second velocity of P is 2 over 3, 2. Cos minus 1 this, or therefore cos minus 1. You could do this in your calculator, but I don't think you get the method marks. (2√5) is here. Okay. Mm. 45 degrees. Nice. Number 6. How many questions are there? 7? 8? Oh, there's 7. Beautiful. We're nearly there, lads. And we have 46 minutes remaining. I will end the stream after 46 minutes. No way, we got 6 people. No way. That's elite, bro. That's elite. It's so elite. 6 people. Wow. Anyway. Let me check on the chat. Let's see what the chat's. Wanted you don't look 18. Yes, sir. give up and fail. Hell no. I ain't got it. I ain't got it. Alright. And theta equals 5 over 12. Okay. Now we have a nice triangle. We can just work out opposite of hypotenuse, adjacent of hypotenuse. Okay, let's actually read the question. Okay, there's a light elastic string with natural length L, modulus of elasticity kmg, has one end attached to fixed point A on a rough inclined plane. Okay, so let's draw it out. We have theta here. We have a fixed point A. I'll just call this A. And this is rough. So we're gonna go ahead. And now I have this rough inclined plane. Natural length L.
اور and a half النار هتعمل تقفلوها. اوكي البوتاجاز هيضرب تقفلوه. او حمزه احط ريمايندر.
ماشي.
تيجي تصلي معايا الظهر يا حمزه ولا انت في in the middle of a test ولا ايه؟
I'll finish mine.
فاضلك قد ايه؟
In 43 minutes.
لا مش هقدر. بوبو تيجي تصلي معايا.
Okay. MG here, theta's there, MG's cos theta, MG sin theta. These are the gravitational forces of resistance. This is not including the force due to friction, of course. It's initially held at A and is then projected with speed this. Okay. I just drew this completely incorrectly. So I'll just call this part A. It's initially here. And then afterwards it's gonna go up the plane. So yeah, it's projected with root 6GL. AB is equal to 3L. And it's at rest when it's at B. So here it's B, V is equal to 0. Okay. Well, first thing I know, we're probably going to have to use work energy principle here. But let me read the question first. Will the coefficient of restitution between the package, coefficient of friction, my bad, mu is equal to a quarter, modeling the package as a particle, show that K is equal to 15 over 26. Okay. can use that. So we can use work energy principle here. So we know the energy before, and we can try and find the energy after. So let's check. Initially we have kinetic energy. Nice. Afterwards we do not have kinetic energy. Before we do, let's assume that at this specific point there's no gravitational potential energy. So let's assume that it starts with no gravitational potential energy, but it gains gravitational potential energy. And then we have elastic strain energy initially. Is it a string? It's a string, okay. So initially there is no EPE, but at the end AB is equal to 3L, so it's extending, because the natural length is just L, the extension of 2L, so yes, we have elastic potential energy. Is there work going in? Nope. Is there work going out? Yes, that's the friction. Next we can find the kinetic energy before and equal to mgh, and lambda x squared over 2L is friction multiplied by the distance. So we know friction max is mu d. Yeah? Hour and a half. Echo, remind me after an hour and a half.
Good afternoon, Hamza. What's the reminder for?
The oven.
Okay, I'll remind you in 1 hour and 30 minutes.
Yes, sir. Okay, quarter. And the distance travelled, it would be 3L. The distance, yeah, just 3L, okay. So I like to do the, no, it's not mu, it's mu r. We're talking about the reaction force, which is mg cos theta, and which is equal to a quarter we did that at the start, 1213 mg, and we can just get 3/13 mg. And then we're going to go ahead and sub in all our values. Is it just m the mass? It is in... M is just the mass. And it's initially... okay, just 6gl here. mg, and the height travelled, you have to consider, okay, which would just be 3L here, and we have theta, so it would be 3L sine theta, because it's the vertical component, and then we've got 2L. L is the length, the natural length. X squared kmg and then x squared is 2L squared because it starts at 3L and it ends at 3L. Okay, the friction multiplied by the distance. Well, we know the friction, we know the distance traveled will just be 3L. So let's make this stuff a bit neater. 3mgl is equal to sine theta is equal to 5/13. So these cancel. MGs all cancel. Nice. Next we're just left with L's. And an LK by itself. Oh, the L's cancels. Okay. There's nothing more satisfying than cancelling out variables. But that's just my opinion. That's just my opinion. Okay, equals 9 over 30. Nice. Oh no, wrong. I'm strong. Less? I'm wrong. What's up? What's wrong? No. What's wrong? Why am I getting it wrong? Okay. Am I multiplied incorrectly? I mean, I don't think so. Oh. 3 over 13. Did I say 2L instead of 3L? That's why. So that's meant to be 9 here. Yes, sir. Let's see. Bismillah. 15 over 13. Yes. And then you divide by 2, you get 26 over 15. Is that what they want? Yes, sir. Let's go. Okay. Next. Part B. Find the acceleration of the package at the instant it starts to move back down the plane from the point B. Okay, so you can imagine that the particle going up and it reaches max and then it starts going back down. Well, we know that the friction direction would change direction, so we have here and we have B. We know the friction, because it's moving this way, friction moves in the opposite direction, and we'll have the gravitational force going downwards, which would just be mg sine theta. We'll have mg sine theta here, and then we have what other forces are involved. We have the elastic potential energy decreasing, so the tension is decreasing. So, but initially at B it's got some tension here, so the tension's also decreased. Okay. We know T equals lambda x over L. We know this is K and G. We know the value of K now. (15 over 26). Okay. We know the extension at this exact point. There's an extension of 2L because it's at 3L. The L's cancel. 15/13 mg. That is the tension. So we can go ahead and do F equals ma. Wow, what an equation. So at this point we have, I'm just subbing the sine theta because, yeah, buddy. Sine theta was 5/13. It's in the opposite direction of the friction, which we found out to be, it's a friction, man. 3/13 mg, which is tension 15/13 mg, which is ma. The m's cancel. See, in mechanics, there's just a lot of cancelling that happens. Negative G equals A. That's it. I think that's it. So the acceleration is just negative G. There's one in terms of G. Just normal free fall acceleration. Nice. Minus 9.8. Okay. Here we go. These tend to be the more difficult questions. Final questions on paper, they're always the most difficult ones. So, 7a. Figure 2 represents the plan view part of... Yeah, by the way, if you don't want to hear me speak, just mute me and do your own study. Yeah? Okay. Figure 2 represents the plan view of part of horizontal floor. A, B, C, D represent vertical walls with AB parallel to CD. Okay. Small ball is projected along with the floor towards wall AB. Immediately before hitting wall AB, the ball is moving with speed V with second and angle alpha to AB, where alpha is in between 0 and pi/2. Okay, so I can only see from this question, this is parallel, A, B and C, D are parallel, so we're going to have to use trigonometric identities. I'm not trigonometric identity. Like co-interior angles, those stuff. I don't know what they're called. Alternating angles, etc. Okay. Show that tan half alpha is equal to a third. Well, there's a tan here. There's alpha there and alpha there. So we're going to consider both collisions. We're going to do collision 1, which is collision AB. We're going to consider two components. A component parallel to the wall, and then one that's perpendicular to the wall. So we're going to have perpendicular to AB. And this one is going to be, I'll show you. So you can obviously do this, and then this will be another angle here. Let's just call it beta here. And we'll obviously have another speed here. Let's call that omega. And we're going to have another speed here. We'll call that z. It doesn't matter. But let's see how we can manipulate this. So this is also going to be, no, is it? Yes. This is also going to be, yes, I have the oven. Okay. Yes. let's do this. So, we are given the coefficient of restitutions. Yes. Okay. So, AB, coefficient is 2 over 3 here. Oh, they're both 2 over 3. That makes it much easier. So, two over 3 V. What's happening? I'm washed, bro. I'm washed. But yeah, it's just gonna be this. Okay. Normally in exam, of course, you gotta be super fast. Like, there's no. You can't wait that long just thinking. Okay. So, because there's a tan involved, then we don't really care about V and omega. I might just divide these together to get rid of the V's, to get rid of the omegas, and we'll just get 2 over 3 tan alpha is equal to tan beta, and I think we're going to try and get rid of tan beta for the second collision. So we have collision 2, which is collision CD. Okay, so we have beta B, okay, omega, so 2 over 3 omega sine beta, because I remember I skipped the question, so I have to go back to it, so I have to go very fast. Okay. Omega sine, 2 over 3 omega sine beta is equal to sine z sine half alpha. And then the next collision, oh, what am I doing? Oh my goodness. Perpendicular here and parallel here. This should just work. Oh no. Okay. Yeah, guys, I'm having a stinker with these. This is meant to be one of the easiest topics. This is a calm question. You should be pretty calm, but I'm struggling. Oh my goodness, how am I doing these blunders? Okay, and now that we have these two equations in terms of tan beta, we can just sub this one into this one. Hence, sub, we can just call this one 4, call this one 5. Sub 4 in 5. It's maybe a bit confusing for the examiner, but you can hold that respectfully. You can hold that. Okay. What? Do I have to separate tan alpha into double angle formula? I think I do. Okay, let's do that. If we want it all into, I'm thinking T formula, but T formula is like nowhere to be seen. It's actually my first time using the equation sheet in this paper. Yeah. So we'll get tan alpha over 2 plus tan alpha over 2, and that is 1 negative tan alpha over 2 squared is equal to tan alpha over 2. Okay, so just make that 2, fine. Fine. Okay, let's just multiply that, why not? I say we divide tan alpha 2. We can divide these. That works. And we'll just get that. We can multiply here. And then you can do just simple stuff here. So 1 over root 9. Oh, it just works. It just works. Beautiful. Yeah, we got it. Tan alpha equals a third. Find the percentage of the initial kinetic energy of the ball that is lost as a result of the 2 impacts. Okay. Well, let's just work out the initial KE first. We're given the mass. We are given. Yeah, I don't think we're given the mass. So just let mass be m. Okay, let's just let it equal m. Because I mean, we're trying to find z basically. So yeah, let's just let it equal m. Oh yeah, because the m's will cancel out if we find it as a percentage. So this is the initial one, just half mv squared. Fine. The final KE is the hard one, where we're trying to find what z is in terms of v. So I think now that we have this information at the top, we can try and use that information to get the second part. In light of this information, yeah, man, I don't know. How long left? 16 minutes. Okay, I'm just gonna go back to. I'll go back to after. There's 8 marker I missed. Let's do this. Okay, we got that. This was a nice question here. Here, this is the question I got. Let me just double check everything else was nice. Okay. Okay, everything else in the paper was nice. It's just that question 8. I mean, no, the 8 mark. Okay. It's the easiest one. The fact that it's the easiest one is just getting me annoyed. Okay. 15 minutes remaining. Let's do this. Oh my goodness. they're not moving opposite to each other. They're moving along the same straight line. Okay. That makes more sense. So, this one's actually going this way. Okay. Makes more sense. So, now that we have all this, we can make this a positive here. Positive here, we can make that 10u. Yeah, man, just reading the question is just a must, I'll be honest. You can't not read questions. Okay, that's incorrect as well. V1 is that part's calm, but the second part, U minus 2. Okay, we should be able to do this. This paper was pretty easy. Okay, there's nothing there that's super difficult. Let's just see the grade boundaries, you know. So these are the grade boundaries. For further mechanics, this is the 2020 paper. It was about 47 for an A. It doesn't say the A. But an A is all I need, basically. 60 to 2.6%. Valid. Should get that in this paper. With nothing there, that's awful. This paper is pretty easy. Anyway, let's just continue this. Okay, that would just be negative. Okay, that's correct. So negative UE add VA, sub 2 into 1. I'm tempted to just redo that all this. There's no point in this. Okay. Okay. After this, I have to go pray. So. Do this a bit quick. Okay. Since E is greater than 0, well, I'm going to say since it's between 0 and 1, VA must be greater than 0, and U is also greater than 0. Fine. And then we sub in VB into VA. Oh no, I think I made a mistake. because it gives us this. I don't think that's positive. Oh wait, it works. Therefore, direction is unchanged for both. Okay, then I can do the second part of that. 6 marks. Oh no, there's 8 minutes. How long left, man? Oh. Job not finished. Job not finished. You know, job not finished. Like, he's just not finished. You know, job not finished. It's not the end of the A. We need to keep at it. Okay, job's not finished. Come on. Let's make all this smaller so I can fit the second part of the question in. Poste pana colio, cota tipo se pana topito pito, pato pito, pito, pato pito. Okay. 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 There's enough space for the part B. Well, I'm just going to do a diagram, of course. You always got to do diagrams in these questions. Well, what do you think I'll get an A-level for the math?
A.
A, why not A star?
Because the bonus are really high, and you might like choke about too many marks in it. And you said the first exam went bad.
I didn't say it went badly, I just said it wasn't the best. Oh, we're getting A stars, alright. Oh, we're getting A stars. How long left? 5 minutes. Okay. Okay. Particle B collides with another particle C. This is moving at this B here. Is moving at U. Oh my god, it's moving at VB. Okay, I'll just make that equal to VB. C stationary. Or is that rest? Okay, it's at rest. So this is 2m here. B is 4m. Okay. And they're saying show that there will be a second collision between A and B. So A is moving already at the same direction here with VA. But so they want me. It's a bit weird, this question. Minutes, come on.
Levine, yeah.
Why am I not doing this? Come on. Okay. No. Okay. Stationary, okay. Okay, I can imagine it to be. Okay. Velocity of B after collision with C. 2 minutes left. Okay. Okay, so you just do VB multiplied by E. That would just be equal to omega B. So let's make that equal to omega B. Okay, now we have omega B here, which is equal to E VB. Okay, 3M was already moving at VA. Okay. So now I just have to prove that if there's another collision, then omega B will be I'm recording myself.
I'm just screaming himself revise. He's lost it.
What do you mean I've lost it?
He's lost the plot. Just revise normally, bro.
What do you mean? I'm doing it well.
حد صلى؟
I'm going to after 1 minute 40 seconds.
حد ما صلاش؟ حد صلى الظهر؟
I will.
أيوة حمزة.
تعالوا صلوا معايا تحت.
Okay, 1 minute 40 seconds.
هي مامي حاطة تايمر للأكل؟
Yeah, I have it on echo. One minute. What the? Okay. Okay. So if there's another collision with A, that means omega B must be smaller than 0. If second collision, omega B must be smaller than 0 because it's moving in this direction. So, because we have the mass of that, we use conservation of linear momentum to get. Oh, I'm not finishing this one. You can do conservation of linear momentum. Okay, before is just stationary. Okay, fine. And this will move with UC. I'll just call it UC. And then this one will move with omega B. Okay, I'm wrong then here. Oh, yeah, it's so over for me. Yeah, it's so over. It's actually. Okay, so. Bro, I was gonna do it. That's wrong. It's over, lads.
Lamine, yeah, man.
Thank you guys for watching, and thank you for tuning in. Yeah, this was the end of Further Mechanics 2020 paper. Study with me because I have Further Mechanics tomorrow. Inshallah, I do well and I get A star. Inshallah, And yes, Assalamu alaikum. See you guys. Bye bye.